All right, so today we are going to be solving trig equations with Pythagorean identities, okay? And so yesterday we just did a lot of solving with algebra, and so today we're going to have to actually involve some of the identities real quick, okay? A couple things I want you to see real quick is that when you see this right here, guys, and you will have this on the test, okay, that your answer should be in radians. Okay, and then when you have it like this, 0 to 360 degrees, that's going to be answer in degrees. Okay. So just to kind of be cautious of that. Okay, and so when we look at this first one here, okay, we can't go ahead and solve it right away because you have a term like sine squared x and cosine x. That's like saying y squared plus 1 equals x, right? And remember, I'm trying to solve for y or x. And so when I have two different types of undefined variables, if I can't factor, which in this case you wouldn't, then it's not going to work out by just going ahead and changing. And so what we want to do is we want to write everything in terms of either sine or cosine. And so when I look at sine squared x, I see, okay, because that square, I think there might be a possible Pythagorean identity that would allow me to do that. And so when I do that, I'm going to get this. I'm now going to have 1 minus cosine squared x plus 1 equals cosine x. And so by changing sine squared x using Pythagorean identity to 1 minus cosine squared x, I now have everything written in terms of cosine x. And so next what I want to do is I want to simplify. I'm just going to drop the parentheses because it's 1 minus cosine squared x plus 1. And so you're going to get this. You're going to get minus cosine squared x plus 2 equals cosine x. Now everything's written in terms of cosine like we had yesterday now, and so really that was my only two new steps there was Pythagorean identity, simplify, and then now let's do what we did yesterday. So we're going to say let x equal cosine x, and so that's going to give me this. I'm going to get now negative x squared plus 2 equals x. Okay? And so now I see x squared and x, two different types of undefined variables. I want to move everything over to one side. And so I want a positive number always in front of the highest degree here. And it's negative right now, so I'm going to go ahead and move everything to the right. And so when I do that, I'm going to have this. I'm going to have now x squared plus x minus 2 equals 0. And now that's a nice trinomial there that we can go ahead and use star method for to factor it down. Remember, a is the 1 in front of the x squared here. C is the negative 2. A times c gives me a negative 2. B is the 1 in front. B is the 1 in front of the x here. So 1 there, and then a is 1 and 1. And so I need two numbers that multiply to give me negative 2 that add to equal 1. It's going to be 2 and negative 1. 2 times negative 1 gives you negative 2. 2 minus 1 gives you 1. And so let's go ahead here now and write out our factors. Remember, simplify fractions here. So we're going to get y plus 2 times y minus 1 equals 0. Sorry, that should be x. I don't know why I changed to y. So that should be x plus 2, x minus 1 equals 0. And so now we go up here, okay, and we set everything equal to 0. So we do x plus 2 equals 0, x minus 1 equals 0. And so when you solve for x, you're going to get x is equal to a negative 2 and a positive 1. Now, what I need to do is what did I do in the third step here? I changed cosine of x to x. I'm now going to change x back to cosine of x. And so I want to know where cosine of x equals a negative 2 and where cosine of x equals 1. Okay? And so what you're going to see is now here's where we look at the unit circle, right? So on the unit circle, I'm looking for an ordered pair where I get x is equal to negative 2. Okay, x is equal to negative 2, and it doesn't exist. Okay, it doesn't exist. And the reason why is because our radius of our unit circle is 1. Okay, and so when you have a radius of 1, the highest answer you can have, the greatest answer you can have is a positive 1. The least answer you can have is a negative 1. So anything less than negative 1 or anything greater than 1, automatically no solution. So we're going to say no solution for this first part. And then now, where is cosine of x equal to 1? Well, I'm looking for an x value ordered pair where I just get 1. And so that exists at 0 degrees, which when we write that in radians, we just write it as 0 rads for radians. And so there's your answer. It's no solution in 0 rads. Okay? All right, number 2. Okay? First thing I see is I see this secant squared x. Okay, and so I'm going to assume I can do a pi with that, which I can, and that is going to equal tangent squared x plus 1 plus tan x minus 1 equals 0. Okay, and so now we're going to go ahead, we're going to drop the parentheses there because it's just addition between the two and combine like terms. And so when we do that, we're going to get this. We're going to get tangent squared x plus tangent x. You can't add those together. Okay, so the only thing that we can do though is that we do have like terms here with the 1 and the negative 1, and so they are going to cancel out, and now you're just left with this. You're left with now tan squared x plus tangent x, which is 0. Now we've got just our equation written in terms of tangent. And so I'm going to go ahead and say then let t equal tan x. And so that's going to be this. That's going to be now t squared plus t equals 0. Okay? I see two terms there. That tells me GCF. And so they both have a t in common. And so it's going to look like this. We're going to get t times t plus 1 equals 0. And so now we're going to go ahead and write out each part equals 0. So we're going to get t equals 0, t plus 1 equals 0. And so that now is going to be this. You're going to get then t is equal to 0, subtract the 1, negative 1. And so you got t is equal to 0 and negative 1. So now I'm going to go to over here and change that t back to tangent of x. So I say I want to know where tangent of x equals 0, tan of x equals a negative 1. Okay? So again, we're looking for an ordered pair that when I do y over x, because remember we're talking tangent, right? We're talking tangent, so tangent's y over x. So when I do y over x with an ordered pair, I'm going to get 0. And so that is going to occur at 0 rads and 180, which in radians is pi. And then where does tangent of x equal negative 1? Well, that is going to occur at the 45 family. And so recall, where is tangent negative? Tangent is negative in quadrants 2 and 4. And so in radians, in quadrant 2, the 45 family is 135, or 3 pi over 4. And then in quadrant 4, the 45 family is 315, or 7 pi over 4. So there you go. So there is my answer. They're all in radians because it asked us to. Okay? All right, last example. We're going to be looking at principal values now. So a couple of things. Really pay attention to this. Okay, principal values. Sign is now restricted between negative pi over 2 and pi over 2. So that's why we say quadrant 4 to 1. Okay? Cosine is restricted now from 0 to pi. Okay, so quadrants 1 and 2. And then tangent is also restricted to 1 and 4. Okay, so negative pi over 2 to pi over 2 for tangent as well. Okay? All right. So when I look at this equation here, this looks pretty daunting, not going to lie. We've got 4 different trig functions. We've got sine x, cosine squared x, cotangent x, tan x. Okay? So I'm writing out 3 sine x. I don't see really much I can do with that. I see cosine squared x which that will somehow get sine involved for me, but I've got this -3 cotangent x tan x. And so what I notice is that the relationship between cotangent of x and tan x is that they are reciprocals. And so what happens when you multiply reciprocals together, you get 1. So if I was to change these both by quotient identities, remember cotangent's equal to cosine of x over sine x times tangent of x as a quotient identity is now sine x over cosine x. And now look what happens there. They're both reciprocals. So when you multiply them by each other, cancel out, cancel out, cancel out, cancel out. And that is just going to leave you with a 1. So now we have this. We now have 3 sine x equals 2 cosine squared x, and then -3 times 1 is just a -3. And now this looks like a much nicer equation. Reminds me of question number 1. Okay? So now the next thing I look at is I see this cosine squared x, which I know, Pythagorean identity. I can rewrite that to be this. I can have now 3 sine x equals 2. Cosine squared x as a Pythagorean identity is 1 minus sine squared x minus 3. And now what I'm going to do is I'm going to go ahead and now distribute that 2 to both terms inside the parentheses. And so now I'm going to have this. I'm going to have 3 sine x equals 2 minus 2 sine squared x minus 3. Okay, let's go ahead and combine like terms on that right side there. And so we have now 3 sine x equals -2 sine squared x. 2 minus 3 is a -1. So now I've got everything written in terms of sine x. And so my next step is to say let y equal sine x. And so when I come up here, I'm now going to have this. I'm going to have 3y equals a -2y squared, because that's sine squared x, minus 1. Okay? So again, look what I have here. I see y and y squared. So what that tells me is that everything needs to get moved to one side, and then we're going to have to factor. And so again, I want this -2 to be positive. It's so much easier when it's positive. So I'm going to move that to the left side, along with the -1 to the left side. And so when you do that, they now signs change. And so I have this. I have 2y squared plus 3y plus 1 equals 0. Okay? I'm going to go ahead here now. This is a nice trinomial. Star method to factor it down. Okay? And so I get a times c, which is 2. I get b, which is 3. A, which is 2. A, which is 2. And so I need two numbers that multiply to give me 2 that add to equal 3. And that is going to be 2 times 1, which is 2. 2 plus 1 equals 3. And now go ahead and let's write out our factors. So we look at our fractions here. And so we see we're going to have y plus 1 times y plus 1/2 equals 0. Again, I'm only interested in solving. So you do not need to take this denominator here and kick it in front, which is what you normally would do if I wanted the proper factors, but I don't need them. Okay, so what I'm going to do is I'm just going to take these, what I have right now, and set them equal to 0 and solve for y. And so what I notice is I've got y plus 1 equals 0, which when you subtract that 1, it's going to give you a -1. And then I've got y plus 1/2, and you subtract that 1/2, you're going to get a -1/2. And so I found -1 and -1/2 equal to y. So now I'm going to go back up here, and I'm going to revert and change y back to sine x. So I want to know where sine x equals a -1 and where sine x equals a -1/2. Okay? So we're doing principal values here, which means sine is restricted from -pi/2 to pi/2. Okay? And so what that means is is that we're only caring about quadrant 4 here, because in quadrant 1, sine is positive. Everything's positive in quadrant 1. So when I look in quadrant 4 for an ordered pair that gives a y value of negative 1, I see 270. But now because we are going to quadrant 4, okay, because we're going to quadrant 4, that answer is going to be negative now, and we get to quadrant 4 going clockwise. So what you should do is you should take whatever theta is originally in quadrant 4, and you're going to subtract that by 360. So when I do 270 minus 360, that gives me a negative 90. But again, it has to be in radians, and so we're going to write it as a negative pi over 2, because that is negative 90 degrees in radians. Okay? Sine x equals a negative 1/2. Okay, so sine x equals negative. So where does that occur? I look for a y value of the negative 1/2. That is occurring at 330 degrees. Okay, which, though we're in quadrant 4 with principal of values, so we're going clockwise there. So 330 minus 360, because it has to be a negative angle, is going to give me a negative 30 degrees, which in radians is pi over 6, and so we just write that as a negative pi over 6. All right, so there we go, guys. I just wanted to say congratulations. That is it for the new material, okay? Please really focus up and study for the test come Thursday. All right? Thanks, guys. I'll see you in class tomorrow. Talk to you then.